Okay, back for another session. We have the Geometry Common Core Regents exam for June 2016. We'll resume at question 13. And in reading, let's see, this one here. Okay, UT, so from here to here is 12. All the way is 42. So RU is 30, right? And if it's going to be RST is a right angle, okay. So this is a question, is this, or what will make this, one of those three right triangle problems? Okay, altitude SU, so that is perpendicular. What value of H will make it one of those? So we have to look at it as which pairs of sides will be proportional, corresponding sides proportional. So after you get used to this situation, you should kind of memorize almost that. We'll go 30 is to H, as H is to 12. Now here's why. The 30 is the bigger leg of the medium triangle, and the corresponding leg on the small triangle, the bigger leg, is H. Now, what we do is, let's consider back to the medium triangle. That happens to also be the smaller leg of the medium triangle, and this is the smaller leg of the small triangle. So that's set up. That's the pairs of corresponding sides. You could write a similarity statement and do the same thing. So h squared equals 360. Square root of h squared, square root of 360. Okay, so what you look at is none of the choices are of this form. They all look like their simplest radical form. So we're going to take square root of 360 and simplify it. A perfect square that factors in evenly is 36. 36 times 10. So that turns into 6 square roots of 10. All right, there's other ways to manage that, but using the calculator, but that's what the intent of the problem is. All right, slope of the altitude. So the key with that is we have to move from A to BC and make a right angle. Now, it's not going to be easy. We're not going to find a nice spot for that. But all that matters is the perpendicular idea, because we want the slope of the altitude. So perpendicular, the slopes will be negative reciprocals. All right. From A to BC. So what is the slope of BC? Well, one way to do it is to count the rise and run. The rise is 2. The run is 5, and it is positive because it's going up and to the right. So a perpendicular line has to have a slope that's the negative and reciprocal. So change the sign, flip the number, and there it is. All right. Okay, so these are similar figures. All right. So cos of j, looks like we're going to have to break this down. That's going to be the same as cos of e. And that's, I think, what they're testing here. That's adjacent over hypotenuse. So that is going to be what's adjacent to e. Okay, right here. EM or ME over the hypotenuse RE. Nope. I'm just going to have to grind through all these choices. So choice 1's out. Cos R, you're looking at the sides, JM, JT. That's on the wrong triangle. So they really want you to understand that it's the same as cos of angle T. Adjacent leg is TM. Hypotenuse for that triangle is JT. TM, JT, TM. It's not JM. Oh, that'd be sine. So, oh, wait a minute. Yep, we need TM there. Okay, that's not it. Let's see. So, keep going. Tangent of T, RM. Okay, so they want tangent of T. Should be the same as tangent of R. And that's EM over RM. So this is upside down. No good. Let's hope that it's this one, or else I did something wrong here. Tangent of E is the same as tangent of J. That'd be TM over JM. There it is. Yep, because that is opposite, and that is a to J, to J, to J. No, to J, sorry. I was on the wrong angle. Opposite of J would be right here. Adjacent to J would be right there. So that's why that's tangent. Oh, and they're checking your knowledge of this. Do you know sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is the opposite over the adjacent. They're testing that knowledge as well as similar figures. So, okay. All right. Let's see. I'm trying to make sure that we figure out what transformation is going to carry A to K. Could be a lot. Also B to L. It's looking like a reflection over the x-axis, right? A to K, those distances are the same. Okay. Keep going, N to D. Yep. So it is a reflection over the x-axis. And it's just because it's the perpendicular bisector of all these um, corresponding points. So A to K, B to L, the x-axis is the perpendicular bisector. So that's why it must be a line reflection. All right. So, okay, for this one, uh, interesting way they did this. They did not flat out tell us that these triangles were similar, but right here what we have is a linear pair, total of 180. So we're going to subtract there and we get 65. Okay, so then these two angles are congruent, and we know those are because of vertical angles. So these triangles are similar by angle-angle triangle similarity postulate. So what we have is proportional corresponding sides. And we just have to set up the right proportion here. Okay, so if you want to make sure that you do that well, you could write the similarity statement ACD. You know, you're looking for which pair of angles are congruent. Yes. So then F is going to be congruent to A. They're marked the same. Let's see. C is going to coincide with itself. And of course, B is going to correspond to D. All right. So now we can use AC as to FC. I just used AC because we have a number for that. Also, DC is given, and its corresponding is BC. So let's see. Oh, and they actually wanted BC, so that's perfect. So AC is 6, FC is 15, DC is 4, BC is X. And cross multiply. There you go. Okay, the seawater problem. All right, so this is a density that they're giving us. All right. Oh, great. So we got gallons of seawater, but we have liters, and we have ounces, but pounds. So there's a lot of conversions that we have to go through here. What we first want to do is look up these conversions. They're on the formula sheet. You have to know where to look for them. Um, so when I look on the reference table, what they have is, let's see, 1 pound is equivalent to 16 ounces. That's one conversion we're going to use. They also have a couple others we could choose from. I'm going to choose the one that says 1 liter equals 0.626 gallons. All right. So that's the one I'm going to choose to use. There is one that goes the other way, gallons to liters, but it doesn't matter which one you pick, as long as you use it right. Okay. So I'm going to convert that 1 pound of salt. I'm going to say 16 ounces of salt instead, because they're equivalent. The 1.2 ounces of salt per liter, I'm going to convert that to 1.2 ounces per. We're going to switch out the 1 liter. Let me do it here. So basically what this means, 1.2 ounces of salt per liter, means we're going to have 1.2 ounces of salt to every 1 liter. Well, I'm going to change out the 1 liter. I'm going to make it 1.2 ounces salt. But I'm going to change it to 0.264 gallons. Okay. Now they want to know how many gallons there'd be in 1 pound of salt. Okay, so here's what we can do. We'll come back down over here. We'll take this conversion, and what we'll do is we'll say instead of 1 pound, it's going to be 16 ounces salt, but we don't know how many gallons. All right, and that'll work for us. Now we can just cross multiply. Let's ignore the units of measure for a minute. 1.2x and whatever 16 times 0.264 is. I got 4.224. Then we're going to divide by 1.2. And I get x is 3.52. And that's going to be gallons. So the nearest tenth is 3.5. All right. Perpendicular bisector. EA is the perpendicular bisector of ZT. So we can go ahead and mark those, which cannot be proven. Okay, so what we could do at this point is, using reflexive property, we could prove the triangles are congruent by side angle side. Triangle congruence theorem, which gets us a lot. Okay. EA bisects angle ZET. Does it? Yes. By corresponding parts of congruent triangles are congruent, we get those the same, which cannot be proven. This can be. Right there. Triangle EZT is equilateral. We don't know that. It looks like it's isosceles, but we don't know for sure if it's equilateral, so it's probably going to be this one. EA is the median, means it goes from the vertex and hits the midpoint. We're going to easily prove that that's the midpoint. So that one's true. Angle Z is congruent to angle T. Yes. Corresponding, we're going to get corresponding parts of congruent triangles are congruent. So that's easily proven. Okay, choice 2. All right, get some space here. Hemispherical tank. Okay. Looks like diameter's 10 feet, so radius is 5 feet. In case we need that. It's a density problem. Full tank. Hemisphere. Okay. Let's calculate the volume for a full sphere. That's right off the formula sheet. You don't have to memorize that. Just be careful that's a cube, not a squared. And make sure we use the 5 for radius, not the 10. All right, let your calculator do the work here. Let's see, I get 523.599. That will be feet cubed, would be the units of measure there. Now we want the hemisphere, which means a half of a sphere. So we're going to, for the volume of that, we're going to take our number, divide by 2. 261.799. All right. Now we got to apply the density concept here. Take a look at the units of measure. Per cubic foot means, let's convert that. 62.4 pounds to every 1 cubic foot, which means feet cubed. And of course, we have our volume. We have the cubic feet, 261.799 for the hemisphere. We just need to know how many pounds. All right, we'll ignore the units of measure now that we've set it up. X times 1's x, whatever 62.4 times that is. I get 1636.3. It's going to be pounds right there. That's the closest. All right, moving on. AC parallel to DE. That means we're going to have similar triangles. You can do that. Reflex the property if you want. So that's going to be by angle similarity. All right. So just from A to D is 24. D to B is 12. DD is 4. We want the length of AC. Really easy to fall for this trick here. Be careful. We do not want to say that 12 to 24 is proportional to 4 to x. Don't want to do that. Easy mistake to make. Before we do that, we've got to actually add these together to get 36, and we really don't even use that anymore. Now, what will be proportional is 12 to 36 is going to be proportional to 4 to x. So we will cross multiply. It's 144. And make sure that that's yes, that's what we wanted. So good. All right. This one can be done a couple of different ways. When I did this one, I did notice when I calculated the slopes, this is a right angle. So you could use the 1/2 base times height, because the base and height just have to be perpendicular. But you're going to have, you're going to have square roots that don't work out nice. You're still going to be able to do it. So feel free to go through that process. I'm going to show a different one that we like to teach our students. When we don't have an easy base and height to work with, there is something we've coined, the box method. I don't know if that's the name of it everybody else uses, but we call it the box method, where we box in the figure that we want to get the area of, and we'll get the area of the box and then basically cut away all the extra triangles. So we just have to count from here to here is 3. From here to here, if we count, is 9. Count those squares, 12. 12 across as well, so it's a square. This happens to be 6. This should be 6. Yep. Okay. So what we have is the area of the box, so to speak, is 12 times 12, which is 144. And I'm going to call these different triangles, 1, 2, and 3. Okay, so I've got the area of triangle 1. That's now you got to be careful. Um, this was a square, so length times width. This is a triangle, so you have to use a half base times height. And it doesn't matter if your 9 is your base or your 12, doesn't make any difference. So that's 54. Area of triangle 2 is down here. 1 half times 6 times 12. And area of triangle 3, 1 half times 3 times 6. All right. So these are all the extras. I'll add those together. We've counted an extra 80, 90, 99 feet. Or sorry, not feet, square units. 99 square units. There's 144 total. Take away 99, you get 45. So that's one method to calculating the area of this. Okay, 23, not fun. Got to read this carefully. What I noticed first was the length of just AB was 10. I was messing around with this problem a little bit. It's a chord that is pushed out of the center by 2 units. So kind of what I looked at is when you look for problems like this, okay, what we have to know is that there's a distance a chord is from the center. And what you do to find that distance is you go to the midpoint and perpendicular back to the center. Midpoint back to perpendicular to center. Now, we don't know where the center is exactly yet, but it's pretty easy to figure that out. If this line is a vertical line, there's the midpoint, and it's 2 units from the center, you have to go perpendicular to this line, which is either over this way, right? You're going to go flat across, or this way. So I don't know which one that's going to be. The center of this circle is either at 1, -2, or it's at 5, -2. So the radius, either way, the radius is going to be calculated like this. 2 squared plus 5 squared equals r squared. So we're going to get an r squared value of 29. Now, if you know this formula, or sorry, the equation of a circle, it takes on this format. R squared is 29, so the number over here needs to be 29. Get rid of those. Let's see, check out the centers. Okay, right here is the indicator. If this were our equation, the center would be -5, 2. That's not what we want. This one has a center of 1, -2, which is one of our possibilities. So get rid of that one, and it's choice 1. All right, tricky problem. That one I have not seen that way, but Common Core is known for that. They're going to try to find a different way than you've seen it before. So, good one. Area of a sector. Okay. Central. All right. So, go ahead and sketch your diagram here. We need a 60-degree angle. We want the area of this sector right here. Okay. Radius is 8 inches. Now, what I tend to do with this is I get the area of the full circle. There's probably formulas your teacher might teach you for area sectors. I always have my students just get the area of the full circle first. And I don't use the calculator here because all the answers are what we call in terms of pi. So I'll just leave it. 8 squared is 64. We're going to multiply by pi, so leave it in terms of pi. Now, 60 degrees is the central angle. So I'm looking at it like this. 60 out of 360, right? 60 degrees out of 360. So you could set it up as a proportion, but I think it gets messier, believe it or not. Can be done. What I like to do is simply say, okay, the area of the sector is the area of the circle times kind of the fraction of the circle. So in this case, it's 64 pi for the area of the full circle, and the fraction is 60 out of 360. Or, and if you let your calculator do that, great. Or it's really just 1/6. Um, so we've got 64 over 6 pi, and then that reduces to 32 over 3, which is 32 pi over 3, right there. All right, that's it for the part ones, and next session will be the open response.